Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody, and welcome to Wednesday night math night. Like Dr. A said, I am Amy Sink, and I am one of the math specialists here at the Learning Liaisons, and we just absolutely love what we get to do, which is hang out here on Wednesdays and do math problems. So we are here to build your competence and confidence in your math skills because you are prepping for that test. And so we want to make sure that you are absolutely ready. These math tests are not easy. And so we want to make sure that you have the skill set to go into that math test feeling ready to go. I am Amy Sink. I am from Central Florida. I have lived in Florida almost my entire life. And I'm an assistant principal right now. I was a math coach for a while. I am certified K-12 math. And so I just love hanging out with you on Wednesdays. I always like to do a little get to know you before we get started because it makes it feel a little bit less like a computer screen and a little bit more like we are sitting in a coffee shop or we're sitting in a classroom doing math together. And so in the comment box, let me know where you're from. Let me know what test you're prepping for. And let me know, get to know you question. Are you an iced coffee drinker or a hot coffee drinker or both or neither? Some people are not coffee drinkers at all. I am definitely an iced coffee drinker unless it's cold outside. And then I love hot chocolate mixed with hot coffee. That is my favorite. But Lord knows it is too hot outside in Florida to be drinking that in the middle of the summer. So I will only do that if it's super cold outside. Otherwise, I am a hot or an iced decaf coffee drinker. Otherwise, I am an iced decaf coffee drinker. So let me know in the comment box where you're from. What test are you prepping for? Are you an iced coffee drinker? Are you a hot coffee drinker? Are you neither? Are you both? I always have a next week section here. I always have a next week section here. And so this section is really for you to be able to tell me, what do you want to see in the upcoming weeks? These sessions are for you. As much as I love sitting here and doing them, these sessions are to help you. And so if there are specific topics that you want to see me go over in the upcoming weeks, please, please, please don't hesitate to ask. I am happy to add those sections, or that content, add those sections in, include questions about that content. And so that is my goal, is to serve you in that capacity. So without further ado, we're going to get started. I will say today's session is very much the theology and the pedagogy of teaching. There are some problems that are just rote solving problems, and we will get to those, I promise. But I did want to let you know that a lot of people comment and let me know, or message me and let me know, that they struggle with that instructional pedagogy and strategy behind teaching. And so I like to sometimes focus on something specific. And so we're kind of focusing on that today with some other stuff sprinkled in there as well. So let's go ahead and read the first problem. A second grade student solves 15 minus 7. A second grade student solves 15 minus 7 by counting backwards from 15, but skips 10, resulting in an answer of 9. This error suggests the need for instruction in fact fluency drills, number line usage to visualize jumps, multiplication tables, place value regrouping. So when we look at this, a second grade student solves 15 minus 7 by counting backward from 15. And so they start at 15 and then they count backward, 14, 13, 12, 11, and they skip 10, resulting in an error of 9. So this might be something that they are counting backwards with orally. This might be something that they're counting backwards with counters, but they're going 15, 14, 13, 12, 11, skip 10, 9, and they result in an answer of 9. What do they need instruction in? So if they are using a strategy, they don't necessarily need fact fluency drills. They don't necessarily need fact fluency drills. Number line usage to visualize jumps, multiplication tables, y'all, they definitely don't need multiplication tables. This is a subtraction problem. And so this right here is definitely an answer that is kind of an outlier, one that doesn't really make sense. Place value regrouping. So while this does require some sort of place value, and that might be a common error that people make because they skip that number 10, which goes right along with place value, they don't need place value regrouping. What this student needs is a number line usage. And so when we look at number lines, 0, 10, 15, if the student can visualize this on a number line, 10, 11, 12, 13, 14, 15, 10, 11, 12, 13, 14, 15, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, then it will help them, and those are definitely not equally spaced, which we would want them to be. As the student counts backwards, they are counting back 7. 1, 2, 3, 4, 5, 6, 7, 10, 9, 8. When the student skips that number 10, then they end up with the wrong answer. And so what we want them to do is be able to see on the number line what numbers there are when they're counting backwards. And so here we have counting backward from 15 to get to the number 8. So again, we don't need to know how to solve this problem. We just need to know the strategy behind it. Let's look at another one. Now, just because this is a second grade student, it would be more of a pre-K through 3, K through 6 problem, but the process of how to eliminate these answer choices really applies to everybody. So let's go ahead and look at the next problem. A pre-K student identifies a square as a diamond when rotated. To correct this misconception, a teacher should ignore it as it's age appropriate, use attribute blocks to discuss properties like sides and angles, regardless of orientation, punish the student for the error, only show squares in upright positions. Only show squares as in the upright positions. So often there are misconceptions when it comes to this kind of stuff because we are so used to drawing triangles like this. And we are so used to drawing squares like this. And we are so used to drawing rectangles like this, that it's important for us to help students realize that sometimes shapes can be turned, or triangles can be turned, or even triangles can look something like this, or like this. And so when we always present a shape in the same format, then it throws students off and they don't identify shapes based on their attributes. They identify shapes based on the way they look. And so, no, we are not going to ignore a misconception, regardless of whether it's age appropriate or not. We want to correct that misconception. Use attribute blocks to discuss properties like sides and angles, regardless of orientation. Absolutely. We're going to come back to that because that is the correct answer. Punish the student for the error? Absolutely not. We're not going to punish them for an error because it's a learning environment. Only show squares in the upright position. In fact, that's what I was just cautioning us against, is we don't only want to show a square in that position, and that's a little bit less like a square, a little bit more like a rectangle, but we don't only want to show a square in the upright position. We want to show that square in a variety of positions so that they don't have this misconception. However, if we use those attribute blocks to discuss properties like sides and angles, then what we're doing is encouraging students to look at the shapes based on those sides, based on those attributes, rather than looking at it based on orientation or position. And so that is why B is correct. Let's go ahead and move on to problem number C. Or problem number C. Wow, I am tired. Problem number 3. Problem number 3. In assessing spatial reasoning, a teacher observes a student struggling to compose shapes. Example, making a rectangle from 2 squares. The most appropriate intervention is moving to advanced topics like symmetry, incorporating tangram puzzles and guided play, focusing solely on naming shapes, increasing geometry instruction time. So while this example right here might be elementary, this as a whole, composing, decomposing shapes, is really beneficial for everybody because K through 12, they're going to encounter composing and decomposing shapes. It's just a matter of what it looks like. So the most appropriate intervention, a student is struggling. If a student is struggling moving on to advanced topics, no matter what, is going to be difficult for the student. So we're not going to necessarily do that. Incorporating tangram puzzles and guided play, that right there is going to be our answer. We'll come back to why. Focusing solely. When you're taking an exam like this, any word that is strong, always, never, solely, only, is typically, if you're really not sure, you could probably ignore or cross that one off, because usually when you're teaching, regardless of what you're teaching, you're not going to go with only doing this or solely or never or always. You're usually going to do it in tandem with something else. So focusing only on naming shapes, that's not going to help us with composing shapes. Composing shapes is something like this. When we look at something like this, and I just disconnected, so we're going to reconnect. When we look at something like this, give me 1 second while I reconnect. Okay, there we go. When we look at something like this, the name of this shape is not really a name. This is an arrow, but it's not necessarily a specific name. And so when I look at a shape like this, what I'm really looking at is I'm looking at a rectangle and a triangle, right? I'm looking at a rectangle and a triangle. And so I'm not going to focus only on naming shapes. I'm not going to necessarily increase my geometry instruction time. What I'm going to look to do is I'm going to want to include tangrams and guided play so that students can naturally compose and decompose those things. And for some reason, my screen disconnected even though it was connected. So now we're reconnecting it. Sometimes this happens. But when they're doing guided play, what you can notice is that they might naturally just put two shapes together and say, look, teacher, I made a butterfly. Or look, teacher, I made a house. Or look, teacher, I made, and they might say something that it doesn't look like. And then you can talk about, what shapes did you use to create that shape? What shapes did you use to compose that shape? And you can start naturally using that vocabulary through that guided play, which is a great way to incorporate something like that. And so that is absolutely going to be the best answer for something like that. I'm working to reconnect this, and if it doesn't work, then we will just abort mission and do something else. All right, we're going to try this again and see what happens. Third time's the charm, right? Here we go. Okay, so let's go ahead and look at problem number 4. To teach rational number operations to a diverse group of 7th graders, which pedagogical strategy is most effective? Which pedagogical strategy is most effective? Assigning repetitive worksheets on fraction operations. Using real-world contexts like dividing pizza to model fraction division. Lecturing on algorithms without manipulatives. Testing students daily on computation skills. So for this one, we are looking at teaching rational number operations. A rational number is a version of a fraction. A rational number is a version of a fraction, and then operations are like your addition, subtraction, multiplication, division, and so on to a diverse group of 7th graders. Which strategy is most effective? Assigning repetitive worksheets is never going to be the most effective strategy. Using real-world contexts like dividing pizza to model fraction division, lecturing on algorithms without manipulatives. So if I'm lecturing without the use of anything else to support my teaching, that's definitely not going to be the best option either, because I'm not capturing all students in the involvement of these problems. Testing students daily on computation skills, not going to be my best option either. Using real world, yes, contexts to model that rational number operation, absolutely, all day, a great strategy. Let's go ahead and move on to the next problem. Triangle ABC is an equilateral triangle, and triangle CDE is a right triangle. If the length of the side AE is 20 units, what is the length of side BD? If the length of side AE is 20 units, what is the length of side BD? So this is a fun one, y'all. This is a fun one. Anytime I have geometry, I'm always going to label my picture. So I'm going to go ahead and do that right now. So the length of side AE, sorry, I keep saying AD, AE is 20. And the length of side, what is the length of side BD? So we're looking for this. Well, what did they give us? They said that ABC is equilateral. That vocabulary word is important. Equilateral means equal sides and equal angle. Equal angles. So that means if ABC is an equilateral triangle, then AC is 8 and BC is 8. Agree? And I know that all triangle angles have a sum of 180 degrees. So if it's equilateral, that means all of my angles have to be equal to one another. So 180 divided by 3 equals 60. So that means that this right here is 60, this is 60, and this is 60. But that also tells me something else, that this is also 60, because vertical angles are angles that are across from each other when I have two intersecting lines and they're equal to each other. Well, if all triangles equal 180 and I know that this one's, and I know that this one right here is 90 and this one is 60, well, I can just do 180 minus 90 minus 60 to equal angle E. So 180 minus 90 minus 60, that means that E is 30. Why am I doing all this work? Because I'm really trying to figure out what this piece is and what this piece is. And I really don't have any other information to help me with that. And so now that I see this relationship between my triangle, right? Now that I see this relationship in my triangle, I now know what I'm going to do. And I'm connecting to my iPad. Here we go. I don't know why. Sometimes it connects beautifully and sometimes it just takes 7,000 times to connect. When we're doing such a fun problem like this, we don't have time for all of that. So I see that I have a 30, 60, 90 degree triangle. And what's so special about a 30, 60, 90 degree triangle? Well, if I draw my 30, 60, 90 degree triangle up here, X is going to be across from the 30, 2X is going to be across from the 90, and X squared roots of 3 is going to be across from the 60. That is the relationship of all 30, 60, 90 degree triangles and their sides. And so now that I have a 30, 60, 90 degree relationship here, I can now figure out what I'm working with. If the whole side of AE is 20, what is this piece right here? Primary teachers, even though you don't need to know how to solve this problem, what you do need to know how to do is part whole. And if my whole is 20 and one part is 8, how do I figure out the other part? Subtraction. 20 minus 8 is 12. So this side is 12. And when I look at my 30, 60, 90 degree angle, when I look at my 30, 60, 90 degree triangle, 12 is at the hypotenuse. So 2x equals 12. What does that mean x equals? Divide both sides by 2, x equals 6. So the 30 is 6. So this right here is 6. Now I can do 8 plus 6 is 14. And I have my answer. This one was a multi-step problem for sure. But it was so fun. Any questions about this? All right, let's go on to our next problem. Simplify. That's all. That's all we're doing is simplifying. Now, it sounds easy. However, this means we are doing PEMDAS. We are doing order of operations. Because I'm going to read this out loud. 8 times 5 minus 3, parentheses, 3 squared times 4, close parentheses, divided by 1/2 plus 9. My order of operations says parentheses first, then exponents, multiplication, then division, and addition and subtraction. However, multiplication and division are paired. Addition and subtraction are paired. And so that means that if I come across multiplication or division in my problem, I'm going to do them left to right. I'm not going to necessarily do multiplication before division. I'm going to do the multiplication or division, whichever comes first, left to right. Then I'm going to solve my addition and subtraction, whatever comes first, left to right. But first I need to do my parentheses and exponents. So I am going to look at this section right here first, parentheses and exponents. I'm going to keep everything else the same. So I have 8 times 5 minus 3 times 3 squared is 3 times 3, which is 9. Times 4 divided by 1/2 plus 9. I'm going to keep everything the same except for the one part that I'm working on. So I'm going to drop everything and keep it the same, but I'm just going to evaluate what's in that parenthesis. 9 times 4 is what? 36. Now, I'm going to keep everything the same. But I'm going to, now, this is no longer parentheses because there's nothing to do inside the parentheses. There's nothing to do to that 36. What I am doing is this is now considered multiplication. So now that I've done my parentheses and my exponents, I'm going to evaluate my multiplication and my division from left to right. So now I'm going to do 8 times 5 is 40. Keep everything else the same. What's the next piece of multiplication or division? -3 times 36. -3 times 36 is -108 divided by 1/2 plus 9. What's the next piece of multiplication and division? -108 divided by 1/2. So now I'm just going to carry this up here because I'm running out of space. 40 minus 108 divided by 1/2 plus 9. When I evaluate that, I have negative 108 divided by 1/2. When I'm dividing by a fraction, what rule am I using? Keep, change, flip. I'm going to keep this. I'm going to change this to a multiplication, and I'm going to flip this. So negative 108 times 2 over 1. Negative 108 times 2 over 1 equals 216 negative plus 9. Now, I am not going to do addition first. I'm going to do my subtraction first because that's what comes in left to right. 40 minus 216 is negative 176 plus 9 equals negative 167, which is A. Questions about that? Remember, don't hesitate to let me know what you want to see me go over in the upcoming weeks. That's exactly what this section is for you. Let me know what you need to see from me in the upcoming weeks, and I look forward to including that as we move forward in the upcoming weeks. All right, let's go on to the next problem. A gym offers 2 monthly plans. A gym offers 2 monthly plans. Plan A costs $10 per month after an initial fee, while Plan B costs $22 per month per minute of calls after an initial $15 fee. What is the cost of the 2 plans in dollars when they are the same price? This should say per month. I apologize for that typo. Plan B costs $22 per month after an initial $15 fee. Okay. So, what is the cost of the 2 plans when they are the same? So, a gym offers 2 monthly plans. Plan A is $10 per month plus that $99 fee. And Plan B is $22 per month plus that $15 fee. You only pay it once, so we're not multiplying it by anything. And let's call M the number of months we are a part of this plan. So I can actually do 10 times M plus 99, and I can actually do 22 times M plus 15 equals my cost, And I want to know when they're the same. What do I know about things that are the same in math? What do I know about things that are the same in math? They're equal. If I set these 2 things equal to one another, I can figure out what that cost is. So 10M plus 99 equals 22M plus 15. And I can just solve it. Minus 10. 99 equals, when I subtract 10 from one side, I subtract it from another side because that's where they're equal. 22 minus 10 is 12. Subtract 15 from both sides. 84. So 12M equals 84. And now divide both sides by 12. So M equals 7. Is that my answer? They asked me what is the cost of the 2 plans. What did I find? The number of months it takes for them to be the same. So if I were to do a table, like let's duplicate this. Let's duplicate this and let's erase all of the hard work that we just did. And let's actually figure out the cost of plan A and plan B after 1 month, 2 months, 3 months, 4 months, and so on. So 99 plus $10 for 1 month equals 109, plus 10 more dollars equals 119, plus 10 more dollars equals 129, 139, month 5, 6, and 7, 149, 159, 169, 179, and so on. Plan B. Month 1, 2, 3, 4. I have a $15 fee plus $22 for the first month. 37 plus 22 for the next month. 59 plus 22, 81 plus 22, 103, month 5 plus 22, 125, month 6 and 7, 147, 169. You see that they are the same. Now, if I go back to my other slide, when I solved, they are the same at 7 months. 7 months. Now, all I need to do is plug that back in. So 10 times 7 plus 99, 70 plus 99 equals 169. What if you chose to plug it into the other one? Let's watch. 22 times 7 plus 15. 22 times 7 is 154 plus 15 equals 169. Pretty cool, huh? So our answer is D. What is the cost when they are the same price? The cost is $169 when they are the same price. All right, we have time for one more. We're going to do one more like pedagogy problem. Then I'm going to throw it over to Dr. A and we will be all finished for the evening. When introducing linear equations, a teacher notices students struggle with slope. Which instructional approach best supports conceptual understanding? Provide practice with the slope formula. M equals y minus y over x minus x. Use graph paper to plot lines and discuss rise over run visually. Assign rote memorization of slope definitions. Focus on solving equations algebraically. When we talk about the progression of mathematic understanding, we are looking at concrete understanding to picture understanding or numeric to abstract. And this seems like it works really well for our elementary friends. But then when we get to middle school and high school, we're like, no, that doesn't work for us. We're just going to focus on the abstract. But research has proven that the progression of math understanding is really concrete, picture, abstract. And so when we're starting linear equations, students are struggling with slope. So what should we do? We should start with whatever is going to help our students solidify that understanding. So providing them practice with the slope formula, that's not a terrible idea, so we can keep that one. Use graph paper to plot lines and discuss what it looks like visually. That's a better answer because we're a little bit closer to that concrete and picture and a little less abstract. This is definitely more abstract. And so we're gonna cross off A and keep B. Assign rote memorization of slope definitions. Just because they can memorize this doesn't mean they understand it. Focus on solving equations algebraically. That is abstract all day. You might by doing that be able to get them to a point of being able to plug and chug, being able to solve a problem and get the answer, solve the problem and get the answer. However, The minute that problem looks slightly different, they're going to struggle. The minute that problem has a fraction or a negative or something that's unusual to what they're used to solving, they're not going to understand it conceptually. But if we use a visual like graph paper to be able to plot those lines and discuss that slope, rise over run, it's going to benefit them even further because we're giving them that concrete or that picture ability to see it. Does that make sense? All right, let's go ahead and close up for tonight. Let me know what you want to see me go over in the upcoming weeks, and I am happy to include it. I hope that you all have a great week, and I look forward to seeing you soon. Bye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well. And on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today. And hopefully we'll see you next week too. Talk to you soon.